Here we are going to have short introduction to design. So design, usually when you talk about something bigger, design of something bigger, you call it architecture. And the definition of architecture is that it is an overall shape of some physical structure. So you can have a house, you can have a boat, you can have a flight, and they all have some kind of design, some kind of architecture. Here we have an example of an architecture. This is Igloo. Igloo, of course, has a specific shape, and in reality, software or architecture is the manner in which various components of the thing being designed are integrated to form a cohesive whole. So here the components are simple. They are blocks of snow that are integrated together, and they have created some kind of a house. I have heard that they are quite effective, warm inside. Anyway, what is important is that it's not enough to look at the architecture. You must always relate the architecture into the environment. So it's the way in which the building fits into into the environment and meshes with other buildings in its vicinity. Here, definitely, Igloo does not fit this requirement, for sure. Even if it would be out of plast, it would simply look very strange. It is also an aesthetic feel of the structure. So some architectures are created just to give this aesthetic feel, not only that they have some functionality. We usually have architectural styles, and instead of describing in detail what the architecture is, you may always refer to some common pattern, to some style of the architecture. So when I want to build a house, I can say I want a raised ranch, or I want to have a summer house which looks like a Cape Cod, or I want to have a beach house that looks like a frame. And in this case, I don't need to describe what the roof looks like, what the windows look like. I simply provide information on the architectural style, and the suppliers of the building would be able to understand me. Regarding software architecture, so architecture is a structure of a system comprising software components. So here we have a system that consists of subsystems, and they in turn may consist of sub-subsystems. Let us call them components. They have their externally visible properties, and these are interfaces, and they have there are relationships between components. One component provides output to the other component, or one component may invoke another component and request some kind of service from this component. So the output of architectural design is a description of a software architecture. So the overall shape of the software system is called architecture. Then it depends. Systems may be big, so even the design of subsystems may also be qualified to be called architecture. What are the advantages of creating architectural design? Well, first of all, as we have seen on the waterfall model, it has shown the phases, and design phase comes after requirements phase. This is truth with modification. Why? Because for many companies, or for building many systems, it is impossible not to look at design and only to look at requirements. Some companies like Ericsson, they have already architectural designs for their systems. And when you gather requirements, these requirements must fit into this architectural design. What are the advantages of having architectural design and using it while gathering requirements? First of all, they help stakeholder communication. If you focus on some subsystem, then you automatically can gather information for that subsystem. So it's a way of structuring discussion. It helps to analyze the system to see whether the system meets some critical requirements and objectives. If you have architectural design within a company, you may often reuse it. So you may either reuse standard architectural style, standard patterns within your company, or you may, as a company, reuse it. You reuse your own. So it's a way of making software development more effective. You do not need to start designing the system from scratch. Also, it helps to allocate work. Like some teams take care of one subsystem, other teams take care of another system. So you allocate the work to teams automatically. And just by dividing the system into subsystems and by creating architectural design, you also manage complexity. You simply may structure your information according to the architectural design. Here I have an example of a design of an architecture of a mental health care system, patient management system. So here we have a system that is composed of various types of systems, the various subsystems, and these subsystems interact with each other, either via the central component here, or I don't know, in this case it is like that, but of course they may also communicate directly with each other. But it does not show on this picture. It just shows that they are related. But what I want to say with this slide is that you don't need to, when you communicate with the users, you may simply use block diagrams, the diagrams that I have shown on this slide. You simply draw the major subsystems and how they are related to each other. And that's enough at this stage. So it is a very abstract description. It does not show the relationship among the components, nor externally visible properties, this model. But it's useful for communication with stakeholders and for project planning. You may simply say, okay, let's gather all the requirements for the prescription system. So you may focus just only on that. And you also assign work on the developing prescription system to one team, one specific team. Okay?